1-6, multiplying and dividing real numbers. So our objective for this lesson is to find products and quotients of real numbers. Our essential understanding is that the rules for multiplying real numbers are related to the properties of real numbers and the definitions of operations. So in this section, again, like last section, which was adding and subtracting, multiplying and dividing, you should basically know the general rules already about how they work. We're just going to dive into a couple situations and try to expand on your knowledge a little bit. Okay, so we know that the product of two positive numbers is positives. For example, 3 times 5 is going to give us 15. Positive 3 times a positive 5. We can think about the product of a positive number and a negative number in terms of groups of numbers. So 3 times negative 5 means 3 groups of negative 5. So that would be negative 5 plus negative 5 plus negative 5, or negative 15. And we can prove this by using our general rules of real numbers. So we can say that 3 times a negative 5 is a negative 15. Okay. Now we're going to divide. We're going to now do the product of two negative numbers. Okay. So we can take the opposite of both sides. Right. We're allowed to do that. The opposites of two equal numbers are equal. Okay. Then the multiplication property of -1 lets us change that to a -1 in the front. Then the associative property lets us group these two together in parentheses. And we leave the right side the same. The multiplication property of -1 then says that this negative right there turns into a -3. And we can see now that the negative on the right-hand side, negative times a negative, multiplication property of -1, turns that into a positive. So we can see how -3 times -5 is going to give us a -15. Now, if that was a little bit confusing, you don't have to remember that all the time, but we do have to remember the basic rules of how how multiplication with negative numbers works. So when we multiply real numbers together, right, the product of two real numbers with different signs is going to be negative. Okay, so that means 2 -3s is going to give me -6, or -2 times 3, the opposite of, right, if we take the opposite of 2 times 3, right, we are going to get -6. Okay, and the product of two real numbers with the same sign is always going to be positive, like 2 times 3 to be 6, like -2 times -3 to be +6. Okay, and some key things to remember when we try to remember all these is that if we have a positive times a positive, that is going to be a positive. If we have a positive times a negative, that is going to be a negative. And if we have a negative times a negative, that is going to be a positive. And of course, we can always flip this middle one around to be a negative times a positive is also going to give us a negative. Okay? So same signs, when I multiply them together, I get a positive. Different signs, when I multiply them together, I get a negative. So let's do some multiplication. So we got 12 times -8. Okay? Different signs. The product of two numbers with different signs is going to be negative. So that is a -96. Okay? Same thing with decimals. 24 times 0.0 or 0.5. Right? That's still two things with the same sign. It's going to be positive to give me 12. Okay? And that you can realize is half of 24, or you can put it into a calculator. Okay? When we multiply two fractions together, same concept, right? Different signs. We have one negative, one positive. okay? And remember how fractions work. We're going to multiply the numerators to give me 3. We're going to multiply the denominators to give me 8. Now, my answer is going to be a negative. The best place to put that is right in the front. The worst place to put it is in the bottom. The okay place to put it is in the top, okay? But we want to get in the habit of trying to make that whole fraction negative. And remember, only one of those numbers is negative. If they were both negative, we'll see that in division, when we get to it, that would be a positive number. Okay? For part D, right, we're squaring negative 3. And remember, when we square something, we are going to multiply it by itself. So that means this is going to be negative 3 times negative 3, which is going to be positive 9. Okay? As the product of two numbers with the same sign, it's going to be positive. Okay? Let's do some of our got it problems. Okay? So we have 6 times negative 15 is going to give me a negative 90. 12 times 0.2. Can leave this as a decimal or a fraction. Since 0.2 is a decimal, let's leave it as a decimal and put 2.4, which we can get with our handy calculator. Positive, because both of them are positive. My fraction is going to be 21 over 50, which is negative and does not reduce. Okay? If you can reduce a fraction, you always should. And of course, negative 4 squared means negative 4 times negative 4. Both of those are negative, so that is a positive 16. Okay? So, that one and this one, part D, tell us something important. Okay? So notice that negative 3 squared is positive 9. So recall from before, lesson 1.3, that a is a square root of b if a squared equals b. So negative 3 technically is a square root of 9. Okay? But when we want the negative square root, right, if we see this, right, that is just going to be equal to 3. Because this symbol right here, the square root symbol, means the principal root. If we want to have a negative square root, we have to put a negative in the front to represent a negative square root. So every positive real number has a positive and negative square root. That symbol, the plus minus, means both. Okay? So if you just see this symbol, we're only going to take the positive. We're only going to take the principal root. Okay? If we see a negative, we're just going to take the negative. If we see nothing, that means positive. If we see them both, we need them both. Now, that changes a little bit when we try to solve equations with square roots, but we'll get to that way later. Okay? So, first one, negative square root of 25. That means we are going to take the square root of 25, which is 5, and make it negative. Okay? And this works because negative 5 times negative 5 is positive 25. Okay? Square root of 4 over 49, do the top. We can kind of think about this like the square root of 4 over the square root of 49. We're going to do them both separately, and we're going to get plus or minus, because we have both of them in the front right there, 2 over 7. Okay? Because 2 over 7 times 2 over 7 is going to be 4 over 49. And we'll look at that concept a lot more when we get into radicals, about how to split up radicals and simplify them like that. Couple got it problems. Okay. Square root of 64 is going to be 8. Positive, because there is no plus or minus in front. Plus or minus square root of 16 is going to be plus or minus 4. Negative square root of 121 is going to be negative 11. And then plus or minus square root of 1 is 1. Square root of 36 is 6. So that turns into plus or minus 1/6. Okay. So next, division. Rules for dividing real numbers are related to the rules for multiplying real numbers. They're pretty much the same thing. And in fact, we can see in a little bit that multiplication and division are really not different at all. Multiplication or division is just multiplying by fractions. Okay? So for any real number a, b, and c, where a is not 0 and a times b is equal to c, then b is equal to c divided by a, right? If we look at that as equation, a times b is equal to c. If I divide both sides by a, we get that b is equal to c divided by a. Okay? And this notation is not the best. In fact, it's very poor and can be confusing. We try to use that notation, fraction notation, for most of our division when we're solving equations and when we're using division in practical applications. But you should kind of know what the division symbol looks like and try not to get too confused by it. Okay, so here's an example. Negative 8 times negative 2 is positive 16. So if I were to divide the negative 8 by both sides, we would have negative 2 is equal to 16 divided by negative 8, and vice versa. Okay. So our key concept for dividing real numbers is that the quotient of two real numbers with different sides is negative, just like it was for multiplication. Okay? The quotient of two real numbers with the same sign is positive, just like it was for multiplication. However, there is a weird one. Division involving 0. Okay? If we are dividing 0 by something, if the quotient of 0 and anything else, our answer is going to be 0, like our example right there. Okay. However, the opposite of that, the quotient of a real number and 0 is undefined. Okay. Always, we are never allowed to divide by 0, and that's an important rule, especially when you get to Algebra 2 or pre-calc or calc, is that there's a lot of weird things that happen that tell you about functions when you try to divide them by 0. So we know that it's undefined and strange things are happening in those graphs. Okay. Let's look at a word problem. So a skydiver's elevation changes by negative 3,600 feet in 4 minutes after the parachute opens. What is the average change in the skydiver's elevation each minute? Well, if we want to solve this, we're basically going to take negative 3,600 divided by 4, which of course, I don't like that notation, so we're going to use fraction notation right there. We have a negative divided by a positive, so my answer is going to be negative. Okay. So what does that mean, negative 900 feet? It means that the skydiver's average change in elevation is down 900 feet. Okay. Same thing. You make 5 withdrawals of, you make 5 withdrawals of equal amounts from your bank account. The total amount you withdraw is 360. So what's the change in your account balance each time you make a withdrawal? So that's, your balance starts at 360, or the amount you take out is 360. Divide that by 5, and we get $72. Okay. So we were withdrawing $72, or sorry, the bank account is changing $72 every time we make a withdrawal. Okay. Next, inverse property of multiplication describes the relationship between a number and its multiplicative inverse. Multiplicative inverses are important. They are the thing that you multiply by your number to make it equal the identity, which in multiplication, the identity is 1. Okay? So, for every non-zero real number a, there is a multiplicative inverse, 1 over a, such that a times 1 over a is equal to 1. Okay? So basically, it is kind of like the reciprocal. Okay? So all you have to do is, if it's a whole number, put it as a fraction. If it's not a whole number, we can flip it over, which is the definition of reciprocal. Okay, so the reciprocal of a non-zero number in the form a over b is b over a. The product of a number and its reciprocal is always 1. So the reciprocal of a number is its multiplicative inverse. Okay, this suggests a rule for dividing fractions. Now, when we see this, here's why it works. This is a proof. Okay, so we're going to show that a over b divided by c over d, why that actually works. Okay, so we got a over b divided by c over d. In order to multiply, and we're going to express it as a fraction first. Then we're going to multiply the numerator and the denominator by the same thing. If I do that, I don't change the fraction. And in this case, I'm going to multiply by the reciprocal of the denominator. Okay, because then that will turn into 1. Right? Because when you multiply something by its reciprocal, it turns into 1. Okay. Inverse property of multiplication says that that turns into 1, and when we simplify, we get a over b times d over c. This shows that something very important, that dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. Okay, very, very, very important theorem there. Okay, so what is the value of x over y when x is negative 3/4 and y is negative 2/3? So we're going to take x over y, which with substitution gives us negative 3 over 4 over negative 2 over 3. Okay. Well, to divide two fractions, I'm going to multiply by the reciprocal of the second function, of the denominator. Okay, so we're going to go negative 3 over 4 times negative, doesn't change the sign, 3 over 2. Negative times a negative gives me a positive, so that is going to be equal to 9 over 8, which is D. Okay, let's do that again with our got it problem. 3/4 divided by negative 5 over 2 means I can multiply by the reciprocal of the second function. So that turns into a negative, because it's a positive times a negative, 6 over 20. Now, never leave things that are not reduced. So 6 over 20, we can still reduce that to be negative 3 over 10. Okay, here's something. Is negative 3 over 4 divided by negative 5 over 2 equivalent to 3 over 4 divided by 5 over 2, all of that negative? Well, let's see. So we got 3 over 4 times negative 2 over 5. And in this case, we have a negative 3 over 4 times 2 over 5. And in both cases, this answer is going to be negative, because we have a positive times a negative. So that's going to be negative 6 over 20, which is going to be negative 3 over 10, just like before. Okay. And it happens to be the same exact problem. And in this case, we're going to get the same thing, because we're going to multiply them first, and then we're going to make the answer negative, so we're still going to get negative 3 over 10. Okay. So hopefully everybody has no problems with these. So find each product, two negatives, that's going to multiply to be a positive. Positive and negative multiply together to be a negative. To find the quotient, 48 divided by 3, that's going to be a negative number. And to divide a fraction by another fraction, we are going to change that to multiplying by the reciprocal, 5 over 4. What's the reciprocal of 1/5? Well, flip it over, so it turns into 5 over 1 negative, which is negative 5. Use a number line to explain why negative 15 in splitting into 3 parts is negative 5? Well, if you cut negative 15 into 3 parts, you're going to see that you're going 5 to the left each time. Determine how many real square roots each number has. Well, 49 has 2 real square roots, right? Because 7 times 7 is 49, and also negative 7 times negative 7 is 49 as well. However, remember, and we'll talk more about later, that symbol, the square root symbol, has only one answer. It's not both answers. Only if you see a plus or a minus in front of the square root do we get two answers until we're trying to solve an equation. But for B, right, what two numbers multiply together to give you 0? Well, it's just 0 times 0. That's 0. There's no such thing as negative 0. 0 is neither negative or positive. It's right in the middle of the number line. Okay, it's smack dab in the middle. So while 49 has 2 real square roots, 0 only has 1. Okay? And that was 1-6, multiplying and dividing real numbers.